Hi everybody, this is the second part of our lecture. I'm going to show again what we have. So we have like this random controlled system. The randomness appears because we have connected in the L system. If you go to tab geometry, we've used the timeline to provide the seed for the randomness. We've created our own generations slider. We've played around with those various shapes. Also, what we've added over here is that in the rules we added that we can scale down proportionally. So if I make it bigger, the shapes are going to show different things, and we can make them much bigger if we want to. And still we have all the variations that we want. Well, I think I might have deleted this one node just yet. So I used a facet node. A facet node in order to create sharp edges. The Gusp polygon is just an angle that you set to say when something needs to be sharp. So you can, if you set it lower, see more edges are becoming sharp. The higher you set it, the less likely something will become sharp. So over here, this is a more or less 90-degree angle. So if I go to 90, probably will get smooth already. Yeah, as you can see. Well, it's just balancing a little bit on that. So if we go for 100, for sure everything is now smoothed. Except for the very sharp edges, of course, which are more than 100-degree angle. So that's a little bit the idea. For the rest, in the revolve nodes, playing around a little bit with this detail. And so we have all these different results. Now these are way too complex. It's because I have here too many generations. If we have something like this, it will make much more sense for dome-like shapes or other shapes which might be useful. Okay, we're going to extend it a little bit. We're going to do quite some different things with it as well. So right now we are only doing just a very simple revolve, and what I want to do right now is I want to create also a kind of pattern that I can use on ceilings or something like that, using this as a profile. So I'm going to create just a new L system. I will copy this one. I'm not using this one right now. A very simple one. And let's go in there again. Okay, changing these values to 1. Zooming in. That's where I need to be. Alright. Now we're going to create a special kind of shape. We want to make sure that we, for the ceiling, we have like a mirror shape which has something like an outgoing shape going to this direction from bottom to top and from left to right. And we always want to make sure that whatever random shape we get, that it's always going to go upwards into the sideways, and when it's sideways it goes upwards again, and so forth, so that we have always generally something from bottom left to top right. Like that we can easily provide with a little formula that allows for these shapes to go that we have like a mirror from one to another, that we have a little formula that this shape is always going to be with the beginning point on the bottom over here and with the end point right at the end over there. So okay, for this we're just going to start over again with a very simple formula. So in this case, A results in F results A results in FA, so every time this is going to be replaced. Right, like this. So far this is simple. Now we're going to add a second one, which is B, and B is also going to have FA, and well, perhaps it's going to be a little bit more clear if I do over here a rotation. So right now the A is every time doing a plus. So this means for each point it's going like F turn 90 degrees clockwise, turn 90 degrees clockwise, and so on. But now for B I'm going to go counterclockwise. And so what I will do is I will change the end over here going to B. So the thing what's happening right now is the first rule has been created, the A. Then the A is being replaced by plus FB, and then B is being replaced by minus FA. So as you can see, it will switch around every time. So every rule at the end changes. Every time a rule is being built, the end changes. Perhaps it's best viewable if you could see it over here. Let me check. So I'm going back to the very first generation, and in the very first generation see plus FB. If we go one generation forward, changes in plus F minus FA. And then again the A is being replaced with the FB. So as you can see, each generation this becomes this, and then this becomes this again. So they switch, they flip around each time. So this is already a shape that ensures us that each time we do something like this, we're gonna get a shape which starts out from bottom left to top right. The thing is also now, I want to add randomness. I want to add randomness in the length of each of those pieces. I don't want to be like a very similar pattern. So what I'm going to add over here is a value. As I've shown you last time in class, if you add a value of 1, for example, then you can overrule between the brackets what the length is going to be. So in order to randomize this, you're allowed to add a random function inside this L system, and as a seed to randomize the value, we're going to use and I'm going to check the help file for that. Go over here, down there, where we can see the variables, the local variables. Well, it's better that I just check over this here. So the local variables, they show me what we have. So I'm going to use the iteration count. So each one that grows has its own count, its own iteration. So that's the one I'm going to use, t. This number is going to be the seed for the length of each of those pieces. And as you can see right now, those lengths are being randomized. The reason why we don't see a difference happening when I use the slider over here is because this random seed has nothing to do with the number of generations that are being created. So each part, this is generation 1, 2, 3, 4, 5 and so on. So that's why we don't have a varying generations count. But what we can do over here as well is we can add this, for example, with another rule or another number. Now, because this is an L system, you're not allowed to have expressions and so inside. You can have expressions inside, but it's better to do it a different way. So just leave it for now as it is. Going to go over here to values, and over here you have a few variables that you can fill in yourself with something. So over here in this variable I'm gonna add $f, which is again reading out the value of the timeline. So b is going to be the number that I'm going to add upon this seed. And so right now, if I start to play with time, the random seeds are changing as well for this shape. So let me explain this again. To do this very simple, I just go over it once again. So right over here, if you put in a number right behind, then you can set the length. The 0.1 is the step size. So I used exactly the same number right now. I'm overruling it, but with exactly the same number. So if I use 2 now, see, it is twice the length. Because I'm overruling this number, it has no effect over here. See? So all the parts in this direction, they're not affected by the step size anymore, because I just have overruled them. So instead of having like a fixed number, I'm going to have like a different length for each one of the lines being created. So therefore I'm going to use the iteration count. So each one being created is going to get another seed number. So rand is the expression for randomness, and rand I can fill in the local variable for the expression. So t is the iteration count. So right now, as you can see, each one of those has different lengths. The only thing I want to do is I want to be able to add variation onto that randomness. Since this number is a seed, I can just add another value to it and the seed number has been changed, so everything changes over here as well. So I go over here, for example variable b, I add the global variable for the time slider, something I've shown you where to find in the previous video, and I'm going to multiply it, for example, with that b value. So right now it's all moving around exactly like I wanted it to be. Now the only thing is the random value, it is a bit too high for me, so I'm going to multiply it by 0.2, something like, so that we have again more or less the same thing. Good. So I'm going to do exactly the same thing for the other one. Only difference is I'm going to use a different value over here. Not a different value, I'm sorry, I'm going to have a different formula for this. And since I'm not going to 0, there's no problem with dividing those. And the only thing is the reason why we see curling the whole thing up is because A is referring to B, and then the end of B is again referring to itself. So the first one is having a plus and the second one is always referring to itself, so every time we have a counterclockwise rotation. So I'm going to set this back to A again, so we go back up to this positive rotation what we find over here. So this is what we have right now. Still, this is not very interesting as a shape for changing ceilings, for a ceiling. That's not a really interesting shape, so I'm going to change that. Let's start with. And what we're going to do now is we're going to add a random chance in which the line is either going to go straight and going to go upward. So I'm just going to cut and paste this over here, and I'm going to create a second function, second A, and this one is not going to rotate at all, and the same for this one, and this one is not going to rotate either. Up. So now we will have to add random chance for this or the next rule to be there. So as I've shown you before, for random chances, for choosing between one of these two rules, you can add over here a double point and a double point. You will have to add how many percent chance something has to be there. So I do this for both of these. Now again, we've lost again the functionality in which we said we want to make sure that the shape goes from bottom left to top right. As you can see, it's showing like very erratic forms and it's like curling up into itself. So if I have like even more generations, you see it's going all bananas, going upwards and downwards, and that's not what we want to have at all. So what has happened? Now it's quite simple, in fact. The problem is that over here we rotated with a 90 degrees clockwise. This results into a B, and the previous one, this results into a B, and the B then went counterclockwise, went upwards again. But the problem is now that we also have the chance that this one is going to be first. So instead of first turning clockwise, this one just goes on straight and then goes to B. So what you might have with all these random chances is that you first turn counterclockwise, it jumps back to A, goes straight up without going clockwise, and then go back again and go again counterclockwise. So 2 times going in the opposite direction. So that's exactly what happened over here, and over here as well, and over here. So each 2 times. So we want to avoid that. So that's quite simple. Each time you go on straight, you say you have to go back to an A, which might be either this one or that one. So we change this one to A, and the one of B that doesn't rotate, that one has to go back to B. And so here again we have again the situation in which we go from bottom to top. So our shapes are getting just a little bit more interesting right now. The only thing is that there are still too many corners, which I don't like. So I'm going to add up the chances of going straight. So we will reduce these ones and we will increase the other ones. So right now, with fewer corners and more straight shapes, or let's say chances are bigger. It still doesn't feel like being enough. Or is it? Well, we have to see. We can still change it anyway afterwards. So next thing is, now we want to make sure that this shape is going to end up with this point and this point. So this point always over here. Well, that's an easy one because it always starts over here, but that the end point is going to be right to this part. In order to do that, we're going to create a bounding box expression again. So create transform node, and we're going to create a bounding box. Well, I probably didn't explain you very clearly what a bounding box is, but a bounding box is like a shape that's completely a box shape, like a cube, a box shape that completely follows or captures the whole shape inside. So you know which are the minimum and the maximum values of those. So the thing now is, we want to move this part into the x direction. So I'm using the bounding box, and for this bounding box, this time I'm going to use LsysSystem2, and I'm using the x max value for that. So if we check it out, it should be moved along to this place completely. Oops, okay, I did that function over here. So this is correct. It jumped completely to the other side. So the only thing I have to do, I have to go like negative to that. So right now we see this shape just being moved along this line. So next thing, we want to make like a completely mirrored shape out of this. Now this is quite easy. For that you have like a mirror node. A mirror node which just makes a very simple copy. By default it's okay because the direction is 1 over here, which is the x-axis, as you can see. And now we just need one other mirror, which I'm going to add right underneath this one. And for this one I'm going to change the vector. I'm going to use the Y instead. So right now we have a completely outlined shape, and if we go around we see all these shapes moving along. We still have some problems over here, but that's something we're going to fix later. That's not of our concern right now. So these are possible shapes. Now the only thing we need to do is to make sure it becomes a shape. Right now it's like one line, but it's not a solid shape. It has no faces, not like this. So that's something we want to change. Now therefore you can use a function which is called join. And joining closes or connects the whole shape into one thing. So basically there's some attributes I need to set first. So I have to say wrap last to first. So when we do this, see, the whole thing becomes connected. Well, to make it a little bit more clear, I'm going to clean this geometry a little bit up. So right now we have like a lot of points over here which are not necessary, so I'm going to clean those. So first step, what I'm going to do, I'm going to use a refine node, and with this refine node I'm able to clean all the points up in between the beginning and the end of the shape. So from 0 to 1, so this beginning till the end of the shape, I'm going to unrefine it. So all unnecessary data is being removed. Well, perhaps there's one thing that I'm going to change, is I'm going to do this operation before I do the mirroring. So if I clean it up over here, I have to do the refinement only once and then use the mirroring. This will make it a little bit more efficient. So what I see over here is there is some detail that has been removed that I didn't want to remove. So I'm just going to lower the tolerance for doing that. So as you can see, the higher the tolerance is, the more it's going to clean the shape, and the lower you set it, the more of the detail it will leave for you. So 0.01 just works fine. And now we join it into this nice little shape. But still, we do have a few problems. Well, I'm going to use a few generations less. And that makes the problem a little bit more obvious to see. So, well, first of all, the joining function makes like a whole polygon out of it, but it doesn't remove duplicate vertices. So I'm going to fuse first all the vertices that are on the same place. It's basically the same function as a merge in Maya. So whenever you do it, all the points within a certain distance are being merged into one. Over here they call it views. So right here we have this shape. We'll look from the other side so we don't have the annoyance of the polygon sticking around. Now the problem is, if we see the numbers over here, we see a nice counting. 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on to 10. But then, instead of going over here to 11, it jumps over to this side, 11, 12, 13, 14, 15, 16, and so on. Now this is a problem, because if we're going to use the sweep function over here, it will use the order of the vertices in order to make a skin out of it. Well, just to be sure, let's try it. I'm going to use this L system as a sweep line, a sweep profile. So I use this one as a profile, and I'm going to use the other one as the profile to sweep around. That's a little bit too big. Just add a transform node in between so that the profile can be a little bit smaller. This will make it easier to see. And the other thing I'm going to do is, first of all, I'm going to rotate this one so it is flat. Transform. Right now the shape is standing up straight. I want to make it flat. So I'm going to rotate it over the x-axis about 90 degrees, something like this. So now if we have a sweep right here, we see we have all the right shapes in there. It's just one little problem. I do have to fix it right now. Thing is, if you see our sweep function, it starts off over here, going immediately to the side. That's not what I want. So I have to make sure that it goes up straight first. So since the A is going to be the first one, I'm going to set the rotation later. So first it goes up straight and then it goes to the side. So this will solve it for over here. And so let's check this one out. Or a shape like this might also be a good one. This one is the easiest. Okay, so we see all these profiles, and now we're going to sweep the output. I'm going to do this with auto closure. Well, it doesn't seem to give any problem. I think I had a problem before with something else then, but I'm going to give you a solution anyway for the time you might have a problem, a similar problem in which you would really need to have like a correct order. So you see over here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So if you would do something like this, this will make it perhaps a little bit more clear. If I would use an add node, like I said, is a node to reconstruct geometry from the number of points. Over here, I'm going to delete geometry and I'm going to create all these points. And as you can see right now, it is creating a line following those points. 0, 1, 2, 3, 4, 5, 6, and so on. But because of the numbering, which is not correct, I'm not able to create a good shape out of it. So therefore you have also a sort function, and a sort, as it speaks for itself, it allows you to reorder how these numbers are being placed. So you can say by x, so they start over here, as you can see. So this is negative part of x, and it rises up, and you can do the other direction as well. You can either reverse the complete numbering, you can do random, which makes it go all berserk, or you can do a shift, in which you just rotate around. So 0 becomes 1, and so forth. You also have an proximity to a point which you can move around, proximity to point, and so as you can see over here, you can move this point around from left to right. I believe when I'm over here, as you can see, I'm not able to actively move it, but you see the point over here. So the points that are closest to this one are going to be selected. So if I move this one along the z-axis, you'll see that these numbers will become the primary numbers. This is a little bit what you can do with the sort function. You have also a vector, which is a little bit the same like saying by x, y, or z, but you have the flexibility to use one yourself or by an expression. But what we're going to do is by vertex order. Since this is like a complete closed polygon, it has a vertex order as well, and the vertex order needs to be in a looping order, because else the polygon can't be formed. So if you do this and you take by vertex order, you'll see that now the numbers have normalized. So 0, and it goes all the way just around the shape till it ends with the highest number. So if we check the add function, right now it is completely correct. So that's why a sort function and how to use a sort function can be very useful in cases that you're making mirrored shapes, or if you're going to combine shapes out of several loose elements. Alright, so over here we have our sweep. We see that our shape is not really correct. It has some sticking gaps inside. So if you go over here with a sweep, you can fix the angle. So now it's going to just stretch out these shapes a little bit, so it's always straight around corners. Right. So right now we do have the ability to create all kinds of different shapes. Although, as you can see, we still have sometimes the problem that if one straight line is being generated, that we're not going to that you don't have correct shapes anymore. It doesn't have any correct orientation, so it can't resolve it properly. So this is again something we need to fix over here in this sweep function. Now I'm not going to do this with adding an extra line. I'm going to do it right over here within the X form. So I'm going to make sure that this shape never has a chance to become like one line, as over here. So the thing I'm doing is I'm going to subtract it with just one number, not such a big number, 0.1 for example. So now I know for sure that it is at least just this little away from the center. So if we see it right now, we already have like a different result, and the shape remains quite correct. Although still one problem. I'm going to set it like this. As you can see, this sharp shape, it's also not really what we want. And that's something that's occurring over here. So what I've said is that we need to connect these shapes, again showing with the edges. But over here you have the blend function, and blending means that it's going to move the positions of both of these points to one common position before it joins. So I'm going to remove that one, as you can see. So right now this is more what I like, what I expected. Just a few things to add though. First of all, again, we will use a facet node. To make the angles sharp where we want it. And then we're going to close the top and the bottom of this one. So that way we have like nice real shapes. So over here as well, I'm going to add a facet node. No, not a facet node, I just added that one. Sorry, I'm a bit distracted. I'm going to add a polycap node. And a polycap, yeah, it's quite simple. The same thing with as with the stairs example. It's just going to close these shapes. And over here I'm going to add a group which selects the whole thing. Shape. And voila, the whole thing is being kept. Well, just one thing, as you can see, the smoothing is not okay. So I'm going to set the faceting at the very end, like this. So right now my shape is exactly as I want it to be. So now we have like lots and lots of possible options and meanings for interesting shapes. And the nice thing is also that we can make it more complex if we want to. We can have like a 32 rule system, which generates for larger areas or larger ceilings more complex patterns. With each of those like having its own distinctive shape. Now, as you can see, for both of the techniques that I've just have shown, I've shown you a way how to handle priorities in which you say, I first want to have shape going forward to the left, then to the right, then to the left, then to the right, then to the left. The same rule you can apply to say, for example, if you have like this round shape, I don't want to have like an exactly same round shape again. I want to minimize those chances. So that will become a more complex L-system algorithm in which you have to copy several things, but and set up the paths on how to go from one to another. But basically, it's doing exactly the same. It's a combination of both of these. So oops, selecting the L system. So if you see those rules, so the same thing by allowing either to go in its own loop or going to another one, to another number, another letter which has like a different set of rules. So this is the end of part 2.